Students, today we will learn about discrete probability distribution for this chapter. So we basically have four learning outcomes for this chapter. The first one, we will learn how to construct a discrete probability distribution. The second learning outcome, you are required to find mean, which is also the expected value, the variance, standard deviation for a discrete random variable. And the third learning outcome will focus on how to use the binomial formula to determine the exact probability of X number of success out of N number of trials. And the fourth learning outcome, we will actually determine mean, variance, standard deviation for the variable of a binomial distribution. Now we will focus on the first learning outcome, which is how to construct a discrete probability distribution. Before that, I would like to introduce to you what are random variables. So random variables are variables that has a numerical description of the outcome for any statistical experiment. So the keyword here is numerical. And random variables are divided into two types, which are discrete random variables and continuous variables. So for this chapter, which is on discrete probability distribution and discrete binomial distribution, we will focus on discrete random variable. And next week's lesson will actually focus on normal distribution, which focuses on continuous variables. So discrete random variable basically are examples of like number of joggers at a park, number of phone calls you receive, number of students in a class. So all these examples, you're very clear, it has to be only a finite number or infinite sequences of values. So for example, 1, 2, 3, 4, 5 or 0 as well. But it cannot be like 0.5 or 1.5. It's not continuous. It's discrete. Okay. Whereas on the other hand, continuous variable is a random variable that you can assume any value in between a certain interval. So for example, the data can be obtained through measurement. And it can involve decimal or fractional values. For example, height, weight, and temperature. So height can be 165.5 cm, and then weight can be 75.5 kgs, and the temperature can be 69.9. That's why it's called continuous variable. Whereas on the other hand, discrete variable gives you a whole number like 0, 1, 2, 3, 4, 5. Okay. So now we will focus on, for this chapter, we will just focus on discrete random variable. Now we will learn how to construct a discrete probability distribution. We will construct a discrete probability table and also a histogram to give you the idea of how a probability distribution looks like. So, for example, if you're rolling a dice is if you have played games, I believe you know what a dice is. It has got 6 sides. Okay, and how we are just rolling a single dice here. So the expected outcomes are when you roll a dice, you might get between number 1 to 6. The probability of getting each number here or each side of the dice, which turns up, okay, is actually between 1 to 1 over 6 for each of it. So the sum of it is actually 1 if you observe the distribution table. So requirement of a probability distribution is the sum of probability is 1. Okay, so 1 out of 6 times 6 is actually 6 over 6, which equals to 1. So the sum of probability is always 1 for any event occurring. Okay, and the sum and the probability value should be only between 0 to 1. So probability of each outcome occurring should not exceed 1. It can be 1 or 0, minimum and maximum 1, but not exceeding 1. Okay, now we will look at the second example where how we're going to construct a probability distribution table followed by a histogram to see how a distribution of binomial distribution looks like. Okay, so for example, if you're rolling two six-sided dice and you're actually summing up the outcomes. So for example, if you roll two dice and the outcome is actually, the total is actually 6 of the two dice top, right? So there are 5 possible ways the outcome can be achieved. So for example, in order to get a total of 6, you roll the first dice and you get a 1. So the second dice say is a 5. So 1 plus 5 is 6. And if it's vice versa, say the first die is a 5 and the second die is a 1, then it's a second way you can actually get total 6. And the third way is, as example, if you get the first and the second die 3 each. So 3 plus 3 is 6. That's the third possible way. And the next is if you roll the two dice and the first die gives you a 4 and the second dice gives you a 2. And the fifth possible way is the first dice gives you a 2 and the second dice vice versa gives you a 4. So this will give you a total of 5 different ways to actually get a total of 6. Okay? And the probability to get each of these is stated as px. So for example, one outcome over 36 different um, possible outcomes, because if you have two dice and you have like 6 sides for each die, so the total possible outcomes will be 6 times 6, 36. Okay, it is 2 out of 36, 3 out of 36 follow on, and 1. So you are just putting the outcomes over the total number of outcomes, which are 36. So bear in mind when you do this, the possible values of x are only between, because x is sum of the two dice, and remember each die is only 1 to 6 and 1 to 6 for the first and the second die. So you only get a minimum total of 1 plus 1 and a maximum total of 6 plus 6, which is 12. Okay, so this is how you construct a probability distribution table. So based on this table, if you okay, the histogram is as below, based on the discrete probability distribution table that we drew in the previous slide. So the y-axis represents the probability. I have simplified the probability, as in it's not over 36. You can also choose to plot it over 36. It's the same. And the y-axis actually is the sum of the two dice just now, the possible outcomes, which are between 2 and 12. Okay, so when you draw a histogram and it looks like that, this shows that this is a discrete probability distribution. So over here, each of the above tables lists certain values of x and their probabilities. So we are trying to determine the validity of this probability distribution. So bear in mind the two concepts. Your probability has to be between 0 and 1. And the sum of all the probabilities of the possible outcomes has for an event has to be 1. Okay? So for example, if you have x 0, 1 to 4, and then this is the probability given. So normally to check the validity, we simply look at each probability value, make sure the value of each probability here is actually between 0 and 1, which it is. It cannot be a negative, it has to be only positive here. So you add all, and your sum of probability over here is actually equal to 1. So therefore, the first table here, the probability distribution is actually valid. Okay, for the second distribution of y, we denote the symbol as py. That means py refers to probability, and this is the outcome that we have achieved from the binomial experiment. So when you first thing you have to study is make sure the probability values are between 0 and 1, which they are, and they should not be negative, only positive. And the second criteria, you check the sum. When you check the sum over here, I got 0.9. So therefore, this is not a valid probability distribution, simply because it doesn't fulfill the criteria of sigma of probability equals to 1. So over here, we are going to focus on how do we do calculations based on a probability distribution table. So for example, um, this is a number of breakdowns per week for a machine based on previous data. So for example, any data, you're given X, possible outcomes, 0, 1 to 3, breakdowns per week, and these are the probability for each of the outcomes to occur. Okay, so find the probability that during a given week, the number of breakdowns for this machine is exactly 2. So if it's exactly 2, it's very clear. If you read it out of the table, over here when X is 2, probability is 0.35. Okay? Between 0 and 2 simply means 0, 1, and 2. So you just sum up 0.15, 0.2, and 0.35, and you get your value of the probability. And next, if it says it's more than 1 here simply means 2 and 3, so you just add 0.35 and 0.3. Okay, at most 1. The word at most once here means 1 is the maximum. So any value 1 and below fulfills the criteria of at most 1. So it should be probability of X equals to 0, sum up with probability of X equals to 1. So you add both and you will get the probability value of at most being 1. So the learning outcome here for this particular slide focuses on how to read a probability distribution table and obtain the probabilities from a probability distribution table. Okay, now we will look into the second learning outcome, which is how to determine mean, variance, standard deviation, and expectation or expected value of discrete random variable. So here I have stated the 4 related formulas. Okay, so as you can see, you can go through these formulas, and each of these formulas we'll be looking into examples in the coming slide and see how to explain and how to use this formulas well. Okay, so mean is x sigma xpx. Okay, so we will look. So we have seen a table that has x and px. So we simply multiply x and px and sum all the multiples. Expected value or expectation is actually also the mean, okay, which is similar to the first formula, just that it has a different symbol. Okay, variance here simply, this is the formula for variance, x squared px, sum of x squared px, minus mean square. Mean is the expected value, or this is the formula for the mean. Okay, so you need to find mean first in order to get your variance, and standard deviation is simply square root of variance. Okay, next we will look into um, an example. So for example, if you plan to open a new McDonald's fried chicken and found these stats for similar restaurants. So percent and years earnings. So 20%, 30, 40, 10, and 50,000 loss. So pay attention, yeah. Certain times loss and profit, you got to consider some signs here. So loss and certain year 30%. No earnings, profit, and profit. Yeah, so using that as probabilities for your new restaurant profits. See, the focus is on restaurant profit. Yeah, what is the expected value and standard deviation? So you're simply required to find mean and standard deviation. So we assume X is a possible profit. So before you actually start any calculation related to discrete random variables, please state what is your success first, which is the X or the possible outcome that you're focusing on. Whether it's the profit or the loss, whether it's tossing a coin, whether it's a head or a tail is your success. You decide, okay? Or the question, based on the question, you actually decide. So for this one, the random variable X is possible profit, because here is said for your new restaurant's profit. Okay, so how are you going to convert this in terms of probability? So we will look at it in the next slide. Okay, so now we are going to calculate the mean and standard deviation. So in order to calculate the mean and standard deviation, it's advisable for you to actually use a table. So you can write your probability values. Remember, the basic rule is sum of probability has to be always 1. So therefore, we divide the initial probability and we get in terms of decimal so that the sum is 1. Okay, and then the earnings is written in terms of thousands. So I divided everything by 1000. Okay, and in order to calculate mean, the formula is sigma of xp, right, or px. So you just multiply p by x on each line. Okay, this is simply negative 50 because it's a loss based on the data provided. Okay, so multiply p and x and you get this column. Okay, and then mean is sum of px, so you just sum all this up. Please consider the negative if it's a loss. Okay, if there's no any negative, you just sum them up usually. Okay, and then you get mean is 25. Right, next part of the question requires you to determine standard deviation. So variance x, this is the formula, sigma x square p times x square, take away mean square. So you have found mean, you need to determine sigma x square p. So in order to determine sigma x square p, you need to square your x, right? So it's negative 50 square multiplied by 0.2. So same goes 0.3 times with 0 square, 0.4 times 50 square, 0.1 times 150 square. You obtain this column. Okay, and then you find the sum of the p times x square, which is 3750. So you have obtained this part of the variance formula. Okay, take away the mean, right? So you can obtain the value for your variance, and standard deviation is simply set of variance. So set of 3125, the value here is 3125, and you will get your final answer for your standard deviation, which is 56. So I just want to remind you, please use a table to do your calculation to minimize careless mistakes. Okay.